Today we're going to talk about how to find the inverse. Remember, we discussed the definition of the inverse function briefly last class. Basically, remember the inverse is that your x and y values are switching. So we're going to have 7 steps to find the inverse. The first step is you're going to determine if f of x is a one-to-one function. I will always give you functions that are one-to-one, so you really do not have to worry about this step. Step 2, instead of having it as f of x equals, we're going to change it to y equals instead. Once we change it to y equals, we're going to switch our x and y values. We're going to solve for y, so get y by itself. Once we get y by itself, that is the inverse. Remember, the symbol that we use for the inverse is f of the negative, it looks like f raised to the negative first power. After we rewrite it as the inverse equals, we're going to note any domain restrictions. And I will tell you, we're going to skip this step since I can't explain this in class. So we're going to skip over step 6, but I still want you to go ahead and write it down. And then step 7, finally, is an optional step. If you take your inverse and plug it into the original function, you should always get x. Alright, let's look at the first problem. So notice we have f of x equals. So our first step, we're going to change it to y equals instead. So y equals 3x minus 1. Now that we have it as y equals, the definition of an inverse is that our x and y values switch. So we're going to change it to x equals 3y minus 1. Now after we switch our x and y's, we said we want to try to get y by itself. So in order to get y by itself, I have to add 1 to both sides. So if I add 1 to both sides, I'm going to get x plus 1 equals 3y. Now we're up close, we still need to get y by itself, so we need to get rid of this 3 right here. So to get rid of that 3, since it's being multiplied, I'm simply going to divide both sides by 3. So if I divide both sides by 3, I'm going to get x plus 1 over 3. So the last step, we said, once we get y equals, that is the inverse. So I will count off if you don't include this. You're going to say the inverse equals x plus 1 over 3. And that is our final answer. Alright, again we have f of x equals. So I'm going to change it to y equals. So y equals the square root of x plus 2. Now again, the definition of an inverse is that my x and y values are switching. So I switch my x and y, so it's going to become this x equals the square root of y plus 2. Now this turns into a radical equation. Notice this 2 right here is underneath the radical. So technically right now the radical is by itself. So all we're going to do to get rid of the radical, since it's a square root, is we're going to square both sides. So when we square both sides, we are going to get x squared equals, if I square the right side, the radical, the square root is going to cancel, so I get y plus 2. Now I need to get y by itself, so I subtract 2, so I'm going to get x squared minus 2. So again, I said I would count off. You're going to say the inverse equals x squared minus 2. That's our final answer. Alright, so again, hopefully you're catching on by now. We're going to change it to y equals, and then switch my x and y. Now this is a fractional expression equation, so remember, to get rid of that fraction, I need to multiply by the common denominator, which is y plus 3 on both sides. So I'm going to multiply by y plus 3 on both sides. In this case, the y plus 3. So I'm just left with a 2. Over here, I'm going to be left with x and a y plus 3. Now, there's 2 things we could do here. We could divide by x, or we could distribute the x. I want you to go ahead and get in the habit of distributing the x. So I'm going to get xy plus 3x equals 2. Now notice, we're trying to get this term right here by itself because that has the y. So to do that, I need to first subtract the 3x. Now to get y by itself, I need to get rid of that x, so I'm going to divide both sides by x. So I'm going to get 2 minus 3x all over x. So my answer is going to be the inverse equals 2 minus 3x all over x. Alright, this one's similar to the last problem we just went over, but it's a little bit more difficult. It requires a few more steps. So, okay, let's first take a look. Let's go ahead, change it to y equals. Now we're going to switch our x and y, so it's going to become x equals 2y minus 5 all over y minus 1. So this time I'm going to multiply by y minus 1 on both sides. So the y minus 1's cancel, and you get 2y minus 5. Over here I'm going to get x parentheses y minus 1. Just like we did with the last problem, we want to go ahead and distribute that x. Now notice, we have two terms that have a y in it. We have this term that has a y in it, and then this also has a y in it. So we need to get both of those on the same side. So let's go ahead and get both of those on the on the left side. So that means I'm going to subtract that 2y. Well, if we subtract that 2y, we still have this term right here. So that means I need to move that over to the right side. So if I move it over to the right side, it's going to become a positive x. It's going to become a positive x minus 5. Now the reason that we got both the terms that have a y in it on the same side is so we can factor. So this right here we want to factor. I can take a y out of both terms. Now to get y by itself, I'm going to go up here so I have more room. Now to get y by itself, I'm just going to divide by x minus 2. So I get y equals x minus 5 over x minus 2. Again, once we get y equals, that's my answer, so I'm going to change it to the inverse. The inverse equals x minus 5 over x minus 2. So that's my final answer. By far, this is probably the hardest one that you'll have to worry about. Alright, our last problem. This one's similar to number 2 because it has a radical. So let's change it to y equals. Change it to y equals. I switch my x and y. Now in this case, I have this plus 3 right here on the outside of the radical. So the first thing I need to do is get rid of that. So I need to subtract 3 on both sides. Now since it's the cube root, to get rid of that radical, I'm going to have to cube both sides. So I cube both sides. I'm going to let you leave it as x minus 3 cubed. You're not going to have to multiply it out. When I cube the cube root, the radical is going to cancel, and I'm just left with y minus 2. Now I add 2 to both sides, so I get y minus 3 cubed plus 2. Y is by itself, so that's my final answer. So the inverse equals the inverse equals x minus 3 cubed plus 2. And we are done. So the key thing here is remembering, alright, I change it to y equals, I switch my x and y values, and then you simply try to get y by itself. Alright, I'm going to give you a short assignment online. I'm going to attach a worksheet that I want you to do, and I will tell you what problems I want you to work on.